Alright, today we are doing polynomials. Now before coming to polynomials, let us recall the base of polynomials. Polynomials is also an algebraic expression. You have studied earlier algebraic expression. An algebraic expression is an expression consisting of numbers as well as alphabet. Numbers are called the constant and alphabets are called the variables. Say for example, let us take a sequence. Say suppose sequence of roll number. Now every school have their own way of writing roll numbers. In our school we write, if suppose somebody is in class 9 section A, we write it as 9101. Similarly, if somebody is in class 8 section B, we would write it as 82. 8 is for the class, 2 is for the section, and if he is roll number 15, then we write 15. Similarly, if somebody is class 7 section A, we write 71, and roll number, suppose if it is 9, then we write 09. Now coming to this one, class 9 section A, roll number 1. Class 9 section A, roll number 2. Class 9 section A, roll number 3. Class 9 section A, roll number 4. Now if you observe this nicely, the first two numbers are not changing. So something which does not change, we call it as constant. They are constant. And these two numbers are changing. In every roll number it changes. If it is 1, we write 1. If it is 2, we write 2. So these can be called as variable. Variables can be represented by alphabets. Now, constant, its value does not changes. Its value does not changes, and in variable, its value changes. Now, these are numbers, and when it comes to algebraic expression, these are alphabets or symbols. Now, numbers you have studied in the previous chapter. Number system can be 1, 2, 3, 4. It can be negative numbers also, 0, minus 1, minus 2. It can be anything. It can be fractions. It can be 1 by 5. It can be minus 2 by 7, anything as such. And alphabets can be any alphabet like A, B, C, or X, Y, Z. X is the most common used alphabet in algebraic expression. Now, you have also learned two types of numbers which we will be using: rational numbers and whole numbers. Now, all whole numbers are rational number, but all rational numbers are not whole number. Rational numbers are those which can be presented in the form of P by Q, a number which is in the form of P by Q, where P and Q are integers and Q not equal to 0. But whole numbers are those numbers starting from 0 and goes on till infinity. Now, if we come to whole numbers, we can write them as 0, 1, 2, 3, so on, goes till infinity. And rational numbers are all the numbers. If we write 1, it is a rational number, 2 is a rational number, 3 is a rational number, then 5 by 9 is a rational number, then any fraction is a rational number. We can write minus 1 by 2 is also a rational number, minus 7 by 4, this is also a rational number. All these are rational numbers. All the whole numbers are rational numbers, but all the rational numbers are not whole numbers. Now you see the formation of polynomials and algebraic expression. If we use rational number as the power of the variable, it becomes an algebraic expression, and when we use whole number as the power of the variable, it becomes a polynomial. Let's see the formation. Now, constant multiplied with variable, and this variable having a power rational number. This thing is called algebraic expression. And polynomial is also an algebraic expression, but it will have constant means number multiplied with variable, and this variable should have power whole number. Now let us form algebraic expression and polynomial. Suppose the constant can be any number. If we take 5, then multiply it with a variable, say y, any alphabet, and then a rational number as its power. Rational number can be anything. I'll write minus 5. So this thing on simplifying becomes 5 into y, 5y to the power 5. This is an algebraic expression. But it is not a polynomial. Why? Because the power is negative. A polynomial should have only whole number as the power. Now, how a polynomial will be? Same thing, we take a constant multiplied with variable, let me say x, and this has a power whole number. It can be anything. I'll take it as 4. Now, on simplifying, it can be written as 5x to the power 4. This thing is the constant. This is the variable, and this is the power. When we take individually, we call it as constant, we call it variable, and we call it power. But when the whole thing comes together, it becomes a polynomial. And in polynomial, we don't call it with this name. We call it as, suppose the same whole thing comes here, we call it as a polynomial, and this thing is called the coefficient of, this thing is coefficient this thing is coefficient of x to the power 4, coefficient of x to the power 4, and this thing is called the degree. Don't get confused. When we take them individually, we call this as the power. You have studied it earlier in junior class, that this is called the power, this is called the variable, and this is called the constant. And when all this come together, it becomes a polynomial. And in the polynomial, we call the number as the coefficient of the variable. Coefficient, whatever variable is here, we call it the coefficient of x, or the coefficient of y, or the coefficient of p or q, anything. This number is called the coefficient of x to the power 4. This is called, the power is called the degree, and this thing is called the variable. It does not change. Now, let us see few more algebraic expression and identify whether it is a polynomial or not a polynomial. Suppose we have 2x to the power 4 minus 3x to the power 2. Now this thing is an algebraic expression. Now in this algebraic expression, the power of the variable are whole numbers 4 and 2. So this is a polynomial. Then suppose if I write 2x to the power minus 4 minus 3x to the power 2. This is not a polynomial, because this thing is not a whole number. It has to, the power has to be a whole number. Then again, if you have 1 by x minus 3x to the power 2. Now this is also not a polynomial, because the power of this x is minus 1. You have studied in laws of exponent that if we have the reciprocal of any number, it is actually the negative power. Actually this x had x to the power minus 1, which we have written as 1 by x to the power 1. This thing has had a negative power, so this is not a polynomial because it had a negative power. Now again, if we have root x, 2 times root x minus 3y, this is also not a polynomial, because the power of this x is not a whole number, it is 1 by 2. So when we have 1 by 2, it is not a whole number, and this x has a power 1 by 2, it is not a whole number, thus it is not a polynomial. If we write 3x only, this is a polynomial, because the power of this is 1. If we write 9x to the power 4 minus 2 by 3x to the power 3. Now this is also a polynomial, because the power, we have to see only the power. The power is a whole number or not a whole number. The power of the variable and not of the number. So this is also a polynomial. Now, hope you understood what are polynomials and what are not polynomials. Next, let us see the classification of polynomials. Classification of polynomials. Polynomials are classified on the basis of terms, on the basis of degree, and so on. On the basis of terms. When you've studied algebraic expression, you've already studied what are terms. What are terms you have already studied. Now, suppose you have one term, then the polynomial is called a monomial. Monomial. For example, 2x, only one term is there, so it is a monomial. Then 5xy, here also we have only one term, it is a monomial. Then minus 7xyz, here also we have only one term, so it is a monomial. Next, if we have two terms, then it is called binomial. Like 2x minus 7, two terms are here, it is binomial. Say 9y square minus 3, here we have two terms, again it is binomial. Then if we have three terms, it is called trinomial. For example, 2x to the power 2 minus 7x plus 4. Here we have three terms, 1, 2 and 3. It is a trinomial. Let me give one more example. Suppose we have 7x to the power 4 minus 7x plus 3. Here we have three terms. Again, this is also a trinomial. Furthermore, if we have 4 or more than 4, these are called polynomials. No particular name for this, we call them polynomials. If we have 4 or more terms, I need not give example for this. If we have more than 3, if we have 4, here we have 3. If we have 4, or okay, let me give one example. Say 9x to the power 5 minus 3x to the power 4 plus 7x square minus 9. Here we have 4 terms, 1, 2, 3, 4. So it will be called as polynomial. For more than 4 is also called polynomial. The next thing is classification on the basis of degree. Classification on the basis of degree. Now, before starting the classification, let me tell you what is degree. Degree means the power of a polynomial. Suppose if I have 2x to the power 5 minus 7x to the power 4 plus 3x to the power 3 minus 2x to the power 2 plus 5x minus 1. What is the degree? The degree means the greatest power. What is the greatest power here? The greatest power is 5. So this is called degree 5. Degree means the greatest power. Greatest power of variable. So this is of degree 5. Now the first is if the degree is 1. Degree 1. If the degree is 1, then we call it as linear polynomial. For example, 7x. What is the power of x? 1. So we call it as linear polynomial. 7x plus 1. Still it is linear polynomial. Next will be degree 2. If we have degree 2 or power 2, we call it as quadratic. Quadratic polynomial. Now, for example, 2x square minus 7x plus 4. This is called quadratic polynomial. Then, if it is of power 3, degree 3, we call it as cubic polynomial. Now, here you will have, for example, 3x to the power 3 minus 7. So degree is 3, so we call it as cubic polynomial. Suppose we have 2x to the power 2 minus 7x to the power 3 plus 9x. Okay, now this is a polynomial or not a polynomial. To identify whether it is polynomial or not a polynomial, we have to see the powers of the variable. Here the powers are all whole numbers, so it is a polynomial. Then we have to see the degree. What is the degree of this polynomial? Degree means the greatest power. The greatest power here is 3, so it is of degree 3. Then whether it is monomial, binomial or trinomial, here it has 3 terms, so it is a trinomial. Then again, what is the coefficient of x here? Coefficient of x is 9. Coefficient of x square is 2. Coefficient of x cube is, what is the coefficient of x cube here? The coefficient of x cube is -7. And what type of polynomial is this? This is a cubic. It is a cubic polynomial. Why cubic? Because it has degree 3. If it had degree 2, then we would call it as quadratic polynomial. Let's see one more example. Suppose we have 2x square minus 7x plus 4. Now in this, is it a polynomial or not a polynomial? To identify, we have to see the powers of the variable. The powers of the variable are 2 and here it is 1. Even if we don't mention, there is 1. So both of these are whole number. It is a polynomial. Then what is the degree of this polynomial? Degree means the greatest power. The greatest power here is 2, so degree 2. And if it is of degree 2, this will be called as quadratic polynomial. Then next thing is coefficient. What is the coefficient of x here? The coefficient of x is -7. Coefficient of x is -7. And what is the coefficient of x square? The coefficient of x square is 2. Then whether it is monomial, binomial or trinomial, this is 1, 2, 3. It has 3 terms, so it is a trinomial. It is a trinomial. Now in the question, you won't be asked to comment all of this in one question. In some question, you will be asked to identify whether it is a polynomial or not a polynomial. In some question, you will be asked about the degree. In some question, you will be asked about the type. In some question, you will be asked about